Okay, so hello, Clojure Conj. Hello, thank you. I wasn't going to say this, but I think I took that picture, by the way, just in case anyone wants it afterwards. Thank you very much. Okay, so I also want to say this is a really friendly crowd. It's so great to see everyone. Like the conversation so far have been brilliant. So it's just awesome to be here. Really, really happy. Yeah, so I'm John Pither. I'm the CEO of Juxt, which is a consultancy that loves Clojure. And I'm here today to give a talk on what is the state of XTDB. So let's get going. I'd like to give a brief intro. So Juxt has been going for 10 years now. It was 10 years ago when we were trying to come up with a name and my Emacs buffer was open and the cursor was like flickering on this Clojure function called Juxt. And it was like, hey, that seems pretty good. So we love Clojure, absolutely love it, love this community, and it's still a pleasure. We still write Clojure every single day, and we want to see more of it. But anyway, my talk today is not so much about Juxt. It's what is the state of XTDB? Why is this a potentially interesting question? So XTDB is written completely in Clojure, and that is like a superpower because it's so productive and the language just gets out of the way and we can concentrate on like the hard problem of actually building a database. So it's been wonderful for that. XTDB has been out for 4 years. But some of you may have seen that we've developed like a new prototype called Core 2. And this has created some questions like what's going to happen to the mainline branch? What is Core 2? Why did we build it? How will it all come together? So I'm here today to come to the Conj, which is like a super awesome place, to give an update, to give some clarity as to what is the state of XTDB. So let's start with a little bit of context. So XTDB, Datomic inspired it. It has that data log query capability. XTDB is unbundled, so some of the primary components like the transaction log, you can use Kafka or you can use JDBC or you can write your own. It's open source, the protocols are there. So it's kind of flexible in how you deploy it, like it can suit your environment. It's document-based, so as opposed to triples, like there's trade-offs there, pros and cons. And XTDB is schemaless, so you can get hold of a document like your Clojure Eden map or a JSON document, and you can just like smash it in, and then you can query it straight away. XTDB is also bitemporal, and I'm going to discuss a bit more about this in a couple of slides. But very briefly, this is what it looks like. So we have a map here. And as I said, you just smash it in. This is a put transaction. The map goes in, and you can query a data log straight away. So just a little bit of history about where we've got to. So XTDB released 4 years ago at the wonderful Clojure North conference. Did anyone go to Clojure North in 2019? Yeah, I definitely recognize a few people. That was an awesome conference. The eagle-eyed members of the audience might spot that the word XTDB isn't actually on any of these slides. Can someone tell me what it used to be called? Yeah, I can't legally say that. So we've since renamed it and we trademarked it, so XTDB is here to stay. We're really happy with the launch of XT, like the community, because it's just so awesome. Really friendly, embraced it and gave us feedback. And it's a community that makes this project fun without a doubt. You know, sharing ideas and seeing where it's got to. It has gone into sectors like healthcare, e-commerce, and finance. And XTDB has been used in different language ecosystems. So here we've got Kotlin, some Python, Elixir. And it has been interesting that people coming from the non-JVM world have picked up XTDB, which has been quite a surprise, but a welcome one. And XTDB has also been embedded into certain platforms, like here we've got BIF and Ageria, which has increased the reach. So far, so good. Really happy with where it's gone to. A very recent update. We've been focusing with XTDB, the mainline branch, on speed. So essentially, you can see on the right-hand side there, it takes half the time now that it used to a couple of versions ago to ingest like 10 million documents. We've also been focusing on fixing bugs, like we don't like bugs, but they do come up, and we fix those. And we've just been focusing on hardening XTDB so it works well. And also from the operational perspective, we've introduced the concept of checkpointing. So right now, a node fires up, it has to play the transaction log to hydrate the local indexes on a particular node. But now it can take a checkpoint of those indexes, put it into S3 or something, and then when a fresh node fires up, it can get that checkpoint, rerun the latest transactions, and it's good to go. So really focusing on just living with XT from an operational perspective, making it fast, harder, and easier to manage. But more interestingly, what is this Core 2 thing? Why did we build it? So we definitely had plans for XT where we wanted it to go. We wanted to add more features that adds more power and really sort of completes the story, I guess, or takes the story further from the temporal perspective. And also, we wanted it to scale out better as well. We wanted it to be able to cope with more data. So instead of iterating in the current code base, we said, well, let's build a new architecture, let's prototype a new architecture that will really service these new features and the non-functional requirements. And I'm really pleased today that the team that have been working very, very hard, they basically killed Core 2. So Core 2 is now gone. It's gone away. If you go to the repo, there's nothing there. And Core 2 is now, this is the big reveal, and my mouse stopped working, the pointer. It's now 2.0. So we have 2.0 is, thank you very much. So we've released an early access of 2.0, and I do want to stress that. Don't go and use it and put all your production data into it just yet. What we're really looking for is feedback for people to tell us what they think of it. And as we develop it more to harden it, to get betas, alphas, and the GA release, then we'll take account of all that feedback and hardening. But today, we've sort of gone out of this prototype Core 2 mode, and now 2.0 is there. Basically, it's what you'd expect from a SQL, right? It's got more features, it's more scalable, and it should be faster than 1.0. So for the rest of the talk, I'm going to talk about what it actually is. So we're going to spend a bit of time going into these three areas, Temporal, Columnar, and SQL. So I would ask everyone takes a sip of coffee, like lean back, it's like a sub-talk within a talk. We're going to go into the world of Temporal for a bit. Temporal. Let's go. Let's warm up. So temporal functionality, people have been dreaming about what is possible in the temporal space. You know, since the 80s and 90s, like Snodgrass proposing extensions to the SQL specification to add in temporal functionality. And database products are now offering it more and more and more, like you saw with Datomic, and other products that are offering more and more temporal functionality. And it's becoming just more well-known and understood, like here's a Fowler article talking about it. And why is this? I think there are a few reasons, but I think without a doubt, one of the major drivers is storage. Like storage is just cheaper now. It's more available in the cloud. So it's not an outrageous proposition to keep the full timeline of a database around. And from a bitemporal perspective, it's not crazy to keep two of them around either. So now we can do this. Let's reflect on bitemporality. So what is it? So this is like a non-bitemporal view. So this is where you've just got one timeline, which is system time, aka transaction time. And in this situation, you can only insert at the end of the timeline. So it's append only going into the future. You can only insert a transaction up until where the last transaction got to and take it from there. So we had a situation on a client site. I did a whole talk about this at Clojure North, so I'm going to condense this. But we had a situation where a client wanted this temporal functionality, right? They wanted to be able to query the database at a point on this timeline. But the problem is that they had all these front office trading systems, and these trades would, they'd have a valid time of when they were known to have been executed. But the trouble is, this is like a really hairy, vast enterprise, and these trades would trickle their way through all these Kafkas and event buses, event sourcing, and you get the idea, before it hit our database. And when these trades got to our database, they were late, and they were out of order. But the client, they wanted to query the database, not when our database saw these trades, but when they were actually known to be valid. So we had a conundrum, right? And this is where bitemporality comes in. With bitemporality, it gives you control over time. You can insert things into anywhere in that valid timeline. That's the beauty of it. And you still have the system time as well. So if you want to do a query against valid time, you can restrict that query to a particular point in transaction time to give you consistent read guarantees about valid time. So valid time is something that can evolve. As you understand more about the past, then you can update the past. But if you want to lock it down at a point on the database timeline for query purposes, you can do so. So it kind of gives you the best of both worlds. That's the contention. It's also really useful, a couple more use cases that we encountered. One is where we had a database and it had all its history, and we wanted to migrate that history into our database. But of course, with a single timeline, you can only put it at the front, but we wanted to insert the history into the past where it belongs. And this bitemporal timeline, this valid timeline, allows you to do that. The other one is corrections. Sometimes you want to correct data in the past, and you don't want to sort of jam those corrections in at the end of the timeline. You want to update the past. So this is what this gives you. It basically hides a multitude of sins and makes living with a timeline easier. Okay, so 1.0. It has this point-in-time query capability. It's more officially known, I think it's fair to say, as a time slice query. So you have a slice in that timeline, and we're querying against that point. But with 2.0, what we really want to offer is the ability to query across time. And this is called a temporal range scan. So this is where we don't know when something was true. We don't know the time coordinate of when to do an as-of query. We want to find out when did this fact first appear on our timeline? Like, when did the database first see something? We might want to say, when did this query start becoming true for the first time? When did these set of logical conditions all apply? Just tell me, when did stuff turn out to be true for the first time? So I think this is best served by a quick example. So I have these 4 transactions, and note that they're all inserting the same product, which is the tire. It says tire entity has 4 versions going in, right? And notice that each one of these versions has a slightly different price. And for each one of these versions, we're inserting that version at a different point in valid time. So we're saying this version is valid from this particular time. And you can see that what is this timeline below, this is what we've created with these 4 transactions. Now, please note that each one of these versions essentially has a valid time period, right? So it has a valid from, which is what you specify when you make the transaction. And then it has a valid to, which is when the subsequent transaction comes in and closes it off. Even the last one does actually have a valid time period, and the end is like the end of time. That's its valid time period. So it's valid from 2021 until the end of time. And that would remain so until someone deletes the product or they insert a new version of the product, which would close off that valid time period. So I hope that makes sense. So given we've got this data here, we should be able to ask a temporal range query. And one example is, when did the tire go above 1,000? Could someone shout out the answer? 2021. Yeah, perfect. It's a little bit of a trick question, because sometimes you might think it's 2020, but actually went above 1,000 in 2021. And that is an example of a temporal range query. We just want to find out, when did this thing become true? When is it true that the tire price went above 1,000? So, yes, there we go. So in XTDB 2.0, the query looks a little bit like this. You can now query across the timeline inside of the query. So it's not critical to understand the syntax completely, but essentially what's happening here is that we're going to products and we're narrowing down to that entity, which is tire. So we've got the ID there, which is just interested in the tire entity. And then we've got some logic vars in play, right? So we're binding out the price and we're binding out the valid from. Because remember, every version's got a valid from and a valid to. And then you see this line that says, for valid time, all time. This now is saying, actually, I want to query across all of valid time. I'm not just interested in like now. This query doesn't apply to now. I want to query across all of time. And then now we're querying for all of the versions that match these query conditions. And then what we're doing below is we're saying, well, find me a version where the price is above 1,000. And then this is typical kind of data loggy query stuff. We say, well, sort by the valid from. The default is going to be ascending. You could put descending if you wanted to, but for our query purposes, it's ascending. And then limit 1, so give me the first one. And then we pull that out. So I'm hoping that that is clear. A couple more examples. In XTDB 1.0, we have a programmatic API endpoint to give you entity history back. And this is what it looks like. But with 2.0, we're moving a lot of the programmatic API into data. And data is better than code for most purposes. So the entity history API goes, it's now part of what you can do in the query. And this is an example of going to history. So we're saying, okay, find me all versions of tire between these two dates, between 2018 and 2022. And you can see we're not just querying across all of valid time there. We've got a for valid time between these two periods. So this is where we just want to do a more sort of powerful search against history of an entity. And this is better than the entity history API because you can combine it with other query conditions. Also, you can see that we're thinning down the API. So that programmatic API endpoint goes. The DB is a value where you open up a DB at a point in time. That also goes because now it's part of data, it's part of the query. So the surface area of the API for 2.0 has been shrunk, and we're putting as much into the query as we can, which is another sort of goal of 2.0. One more example. This is a temporal join. So now we're joining across entities and across time, valid times of those entities. So we're hitting products twice here. The first one, we're going for tire again. And this time, we're binding out not the valid from or the valid to, but we're binding out the validity period. And likewise, below that, we're going to products, and we're getting all products. And then you can see for all products, we're saying actually where they're not equal to tire. So now we've got products that aren't tire, and we've got the tire versions. And then we've got a temporal predicate here to say, find me versions where the validity time of the tire overlaps with the validity time of a product that isn't tire. So basically, find me all products that exist at the same time as tire. Another example I quite like of this is, imagine you're ingesting sort of records about people, and you might say, find me all people that I used to work with when I worked at a particular company. You can do that kind of thing. So temporal joins. Note this overlaps temporal predicate. This is working against periods. And when you're working with temporal data, as I mentioned, you've got these versions and they have periods. So we've got quite a few temporal predicates that you can use, and overlaps is one of them. So we've got things like contains. Does this period contain like another period? Does it lag behind? Does it succeed? And I hope this is going to become quite an intuitive way. Like once you get used to the idea of querying across time, then I hope that these predicates become easy to reach for, like easy to understand and to grok and to reason about. So this is obviously meant for 2.0. We've done a lot of work to rebuild the query engine. It's a new temporal query engine that we've got. I'm not going to go into the details of it in this talk, because it definitely would be another talk. But everything is open source. We have a bibliography that you can go and check out the white papers. And please do come along. There is a branch called 2.0 in the main repo now. And we're also available on a discuss.xtdb.com if you just want to come and ask us questions and find out how we've done it. That's the end of the temporal section. I just add that we're quite excited about this because XT has always been bitemporal, but it's always been kind of lacking because, yes, you have a timeline that hides a multitude of sins that's more flexible, but there's no real power to query what's in that timeline. And now with 2.0, we're starting to make moves in that direction. And actually, XTDB does stand for a cross-time database. So I kind of feel that we can now start to make good on the promise of what XTDB can offer. So that's temporal. Have another swig of coffee, and let's talk about Columnar. So this is the data architecture of 2.0. Essentially, we wanted just to scale and to be able to process tons of data, like really push the boundary in terms of the amount of data that XTDB can handle. And with 1.0, it's good for a lot of use cases, but each node has to build up local indexes, a full copy, to then service query. Which, is good, but it's not perfect because those nodes become quite heavy. And it takes a while to sort of fire one up. If there's a big transaction log, it has to replay to build up those local indexes. So we wanted to break that. For 2.0, something we always wanted to do, and it was a goal from the very start, is to separate out storage from compute like other databases do. And this is where a node fires up, and it doesn't need all of the data locally. It just, when a query comes in, it can get the data that it needs to satisfy that particular query. And then it's going to build up caches, and it's going to be effective to service those queries from then on. And the approach that we've gone for is Columnar. So I'll have a quick example of what this looks like under the hood. If it works, awesome. So we have a document coming in on the left-hand side. We are essentially, the ingest pipeline in 2.0 is going to shred that document. It's going to take those field value pairs. And each field is basically a column, right? And in the columnar approach, all you're really doing is building up a file that has all of the values for that column. In this case, for this field that lives inside of a document. So the document comes in. We've got the ID there, and all of the IDs we're going to put into the ID file. We're going to build up this ID file. And then all of the names are going to go into a name column file, and all of the ages are going to go into an age column file. And you can see that we build up some metadata as we go about this column file that we're building up. And the metadata contains things like the min value that we've seen in this column file, the max value, and also the row start. The row start helps us to stitch everything back together when we want to hydrate or reconstruct a tuple. We have a Boolean filter as well to tell us what's in that column file, like this file definitely doesn't have this data or might have this data. So when the query engine is doing its work, it can consult the metadata files and work out which column files it needs to pull down from storage to satisfy a particular query. And here we go. Column files are becoming really popular now for modern databases. There's a few reasons for that. One is that because you're storing files of values, it compresses down really, really well. So it's really fast to get hold of and to process. And the technologies that we use are just very, very fast as well and efficient. Another advantage of column files is that, let's say that you have 20 columns for a particular type of record, and you rarely access 2 or 3 of those, then you can have like retention policies on those particular column files to say, these column files we very rarely access, so let's have those managed in a cheaper way, like AWS Glacier or something to have tiered storage, so it's cheaper to store the more rarely accessed files. The technology that we're using is Apache Arrow, and this is basically a data format. It has a specification, so there's lots of different implementations from different languages and different tooling ecosystems. And we like Apache Arrow because, first of all, it's open. So we store our data using Apache Arrow. So somebody, if they wanted to, could ingest data into XTDB, and then they can get at that data and even query it without using XTDB because it's all in Arrow. The metadata is there in Arrow. It's completely available. This isn't quite the case with 1.0. With 1.0, we serialize everything using Nippy, which is an awesome Clojure library. But if you're a Python user and you rock up to it, it's going to be like, what's going on? Apache Arrow is blazingly fast. So one of the challenges with XTDB 1.0 is that we store everything locally in a KV store, like RocksDB or LMDB. And no matter how hard you try, how hard we've tuned it, and there's lots of work gone into it, you've still got that barrier where when you take data out of Rocks, you have to deserialize it, you have to manage the memory buffers that you use as part of that deserialization process. But with Apache Arrow, we have a really good upgrade path where we can push a lot of the operations that we need close to the Apache Arrow data itself, so we don't need to deserialize until the very last minute when we give the users back their data. So it's tremendously fast. So column files, it's great for the analytical use case where you need to aggregate or traverse lots and lots of values of data. And hence, with XTDB 2.0, we want to cope with these vaster, larger data sets. We're also going to keep the transaction path fast as well by having a hot path, and we're going to endeavor to make it faster than 1.0. So, Apache Arrow is pretty cool. The last area I want to mention, and I've had some questions about this, is Core 2 just going SQL and dropping Datalog? We're definitely not. We love Datalog in Juxt, and we use it. We love the power of it, the way that you can compose it and build it up. Datalog is here to stay, and we love it. But we're also introducing first-class SQL support. So we've built a SQL parser, we've built a SQL relational engine to power it, as well as the Datalog. And now XTDB supports SQL out of the box. But it's not just any SQL. It's SQL that is dynamic. So just like with the Datalog, you don't have to specify the table definitions up front. When you ingest a document, those tables will appear, and then you can query them using SQL, or you can query them and with Datalog as well. We're also offering temporal capabilities that I've discussed. They're all available via SQL, but also as part of the latest SQL temporal specifications. So we hope that people will come to XT because they want the temporal functionality and it's in tune with what has been specified. So this is what it looks like. This is a big change to the API. So now when you insert into XTDB, you have to specify essentially the table that you're putting documents into. So now we basically have a partition, whereas before we didn't with 1.0. And this is what the query looks like. When you do a query, you have to specify the table, and that's what we've got with products here. Notice we've got this document matching syntax, which is a bit different to triples now. So here you can specify, I want to find documents that match documents that look like this submap. And then below, here's like a SQL stringy example of the same query. So, Datalog and SQL, now good friends in XT. They both compile to the same relational plan. In terms of relational engines, they've been around for 50, 60 years, so we're able to use all of the research and able to make it really, really fast, and we've tuned it. And the plan then gets passed to an execution engine, which has all of the scans, join filters, does all the stuff that you need to do. We have the job of building a layer of light and adaptive indexes that we call them to sit above the column files. So we only go and get the column files when we need to. So we can obviously speed things up and keep covering, keep basically caches to just make it as fast as possible to work with that data. So that's it. That is XTDB 2.0 in a nutshell. I guess 3 things that you could remember about it is that it's got more temporal functionality. The architecture is now columnar, so it's been revised. It can cope with way more data now. It's more versatile. And it now supports SQL first class. This is what the future looks like. So we have an early access available now. We are really in listening mode. So we'd love people to go around and play with it. The API has changed. Tell us what you think of it. And we're ready to get that feedback and want to discuss it. We have a target of getting towards a GA release by the end of the year. So we're going to be hardening it. We're going to be hardening with the experience of 1.0, all the test cases, everything, the performance harnesses, all of that is coming across to make it as hard as we can based on what we've learned. We also want to supply a XT as a service, a database as a service. And we can do this because we've thinned down the API, so it has a bit more of a remote first type feel, although you can still embed it if you want to as a kind of power usage scenario. And that's it, really. I want to, so this is the URL for V2. Go and check it out. We've published that today, I think. And you can get hold of us on this discuss.xtdb.com site. I want to take this opportunity to I want to say some thank yous. So I want to say thank you to the Clojure Conj for letting me come here and give this update. I want to thank the community that has been built up around XTDB. We've got some awesome members that just sort of help out and advise like different users, and it's a really sort of vibrant scene and lots of ideas and feedback. It does make the project fun. And I want to thank the XTDB team who have just worked tirelessly to take this prototype of Core 2, but to make it a version 2 and to get it back in the main project, and we've committed to it, and they've worked tirelessly to do so, as well as keeping 1.0 going and hardening that as well. I'm not the most technical person on this team, but if there's an easy question, I guess I can take it now if there's time. But if not, then in the hallway, please do come and grab us, and we can get down to the weeds.
We've got a mic here.
Cool. But thank you very much. That is the talk. Done.